There we go. I am your FSR for Western Washington North, Jamin Meyer, FSR Field Service Representative. If you don't have this number, put it in your phone right now. You can call or text 253-620-8282. That is our text services line for Trane, American Standard, and Mitsubishi. Fastest way to get a hold of us is text in a picture with the data plate of what you're working on, your name and name and who you're with, of course. You'll get built in this system, so you won't have to do that again. And then text a picture of what you're working on, because the data plate doesn't, if you call and leave a voicemail, we may have to listen to it 3 times to get that full model and serial number. And then, of course, we need model and serial number of all the equipment. That way we can keep track of it. And then if you have ongoing issues, we can always refer to the last ticket running that serial number. So that's critical. Texting in picture, again, there's no discrepancy, and we can copy and paste. Everything just goes quicker. So I do recommend texting to get in front of us. We do try to get to everybody within 20 minutes. We appreciate your patience, because some days are more overwhelming than others. Ameristar Run True Inverter. This is a pretty stout little unit. Nice handholds. It's high efficiency inverter driven heat pump by our first high efficiency inverter heat pump by Ameristar Run True. Compact design for the small location, so it's like the ductless. You got your single fan, double fan. It's compatible with any 24-volt heat pump thermostat. It's got great ratings of the 8.5 HSPF, 15.2, and has ratings with coil. Here, let's do the red. There we go. So coil only matches, so really it doesn't care what furnace you're putting on there. Of course, we want to make sure that we got the 400 CFM per ton, and we're matching the airflow up per tonnage. It's a pretty quiet unit, 67 dBA, 10-year registered warranty. So make sure those warranties are getting registered. Of course, to the homeowner, if the homeowner sells and you get a new owner in there, there is an option for that new owner to carry over warranty. I think it's $99. So be aware of that. You might want to stress that if you come across a new home ownership that's having you out there and you run the warranty. It is neat cold climate certified. It's got that plate fin coil with the bluefin coastal coating, so it stands up against the saltwater attacks a little bit better. Air handler is solid construction. It's got a factory installed TXV multi-speed fan motor. This is the E4AH5E is upflow horizontal right left only. Okay, so keep that in mind. This is not a downflow. We'll go over the downflow air handler in a second. Field installed electric heat kits. So we got a 2-ton, 3-ton, 4-ton, 5-ton. Of course, that 2.4 divided by 12 is a 2. 3.6 divided by 12 is a 3, and so forth. So that's your tonnage. And the I used to have those committed when I was doing installs. I had all the dimensions committed to memory, but I do not with this. But 21-inch depths, pretty typical. We got 21, 21, and 24.5 wide units. So it's an economical inverter, so it's cost efficient. It's a good quiet system, and you have an add-on heat pump option to existing gas furnace, any brand. So that's kind of nice. You can slap a coil under any existing furnace. I do recommend always swapping out a furnace if they're going with the new system, but if they got a 4-year-old furnace, then so be it. Can be AC only with the dip switch. So it's just, if you just want an AC, you're going to set it for a dip switch, and it's just AC, no heat pump. So you'll keep the gas heat with AC. Remote diagnostics with the Trane American Standard thermostat, 824, 24-volt thermostat will have the remote diagnostics. And of course, it's backed by Trane, and it's seat tested. Applications and orientations. So equipment selection, we have the air handler, we have a indoor coil TXV, we got the 824 thermostat. That's horizontal left, horizontal right. Of course, when you're converting horizontal, you're going to have to swap that coil, and I'll have a couple slides on that. The E4AH5E takes the Bay Heater 16 series heat strip, so it is different than the A4AH5 for downflow only. Takes the Bay Heater 15. So when you're ordering those, make sure that you have the right heat strip. 4 TXC coils with the TXV. Everybody knows that when you're brazing in this suction line right here, make sure that you take the TXV bulb off, because you can overheat that pretty easy and ruin the TXV. We see it quite a bit. Here's a 724 black and white, pretty basic. Your 824 has the color. Any 24-volt stat, any 24-volt stat, 2-stage stat, 3 heat, 2 cool. So if you like your Honeywells, I don't recommend Nest. A lot of homeowners like them. It's got a 5-tap. So this is the E4AH5E. It's got the 5-tap constant torque motor. There'll be some dip switches in here. I'll touch on the dip switches. Total external static pressure, we're up to 0.8, 0.1. Of course, 0.5 is ideal. External static going over, if we took static pressure on the return, and the supply, we should be about a 0.5 inches of water column. It's got a TXV, and there are strainers in here, so they can easily get plugged up. So we do have a strainer in here before the TXV. So we want to make sure that we're bleeding with nitrogen, or we're bleeding nitrogen through while brazing. You got the 4 models of the Bay Heater 16, the heat strip kit for this, 15 through 20 kW. It's a pretty tight cabinet, got 2% or less air leakage. R4 insulation in there. It's a nice cabinet. 3 positions. Again, this E4AH5E is not downflow approved. And the only reason is because they can't get the water drainage correct, right? So technically it would work, but you're going to have water blow off. And you'll have it all through the ductwork. So they couldn't get that correct. So no downflow. Our 24 and 36 are 2-ton and 3-ton air handler. You got 21 by 21 and 46.5. I know, I wish they'd find a way to shorten these up. We got a 4-ton and a 5-ton, 24.5 wide in coils, 56 tall, with a 3/8, 7/8 connection. When it ships upflow and horizontal right.
Hey, mate. Not much. What's going on?
Jim, we can hear you.
Flash from yesterday.
No, I called everybody, left messages for everybody. I had one guy the one that had the
Hold on, let me see if I
flat
can mute
system.
him.
I told him what he needed to do. He kind of backlashed a little bit, but they do. Yeah. Well, he goes, well, I ran out of nitrogen.
There we go. I apologize for that. Okay, ships upflow and horizontal right. Again, downflow not approved. We can't stress that enough. If you need horizontal left, it's not too bad, but you're going to pull all your screws. There's going to be rails up here that they're going to slide in. So you're going to pull that entire coil out, and you will rotate it 180 degrees and slide it back in. Ships upflow horizontal right, horizontal left requires the coil to be turned. Sorry, kind of duplicate. This is pulled from the installation manual, so that will walk you through. But again, it's pretty straightforward. You're going to just swap it and then move that drain pan connection. You'll have to pull that screw too. There's our coil. There's that strainer we were talking about. So if that thing does get plugged up, we can take a temperature reading on either side, or both sides, and if there's anything over a 3-degree temperature split, it is plugged. So we're gonna have to replace it. Horizontal units must be configured for right-hand air supply or left-hand air supply. Horizontal drain pan must be located under indoor coil. Failure to use the drain pan can result in property damage. Well, I hope everybody knows that. Make sure your drain pan, if you got to swap it to the horizontal, here's our horizontal drain pan. Make sure that's on the bottom of the unit to collect that moisture. When the air handler is installed vertical, please block the upper drainage hole with the cover. I know in some jurisdictions, they do have you pipe out both. So here's our primary. If the primary plugs, our secondary is going to drain possibly into the drain pan, which if you have a drain pan with a wet switch, it's going to trip the wet switch, right? So I know in a lot of jurisdictions, they are making us pipe out both pipes. The primary goes to the outside, secondary goes into a drain pan or some kind of wet switch. Let's see, when the air handler installed vertically, please block the upper drainage hole with the cover. The lower right of the drainage hole is connected with the drainage pipe, and the lower left of so that's just same. Remove one of those plugs and put it back in the upper plug. So just don't leave that open. I don't see that too often. So when converting it left to right, you'll see you'll pick the lowest one and the one to the right for your primary and your secondary, and you will cap that third upper hole. This is important. Hopefully we're all using P-traps. I've seen some pretty minimal P-traps, but this is a P-trap. I know we sell them pre-made. You can make your own. I've seen some traps though to where they are about equal. We need to have the point where it's lower so the water can drain, but we have water standing in there. So this is a negative pressure cabinet, or else it would pull the air back in and not drain correctly. So this allows the water to drain smoothly. And then please, and this goes for gas furnaces too, we need that atmospheric T, because once it hits it, if we don't have an atmospheric T and this is just a 90, it's possible that it won't drain right there and it'll create a suction. So if it's got the breather T in there, it will allow that to drain. That could be going straight into the bottom of a condensate pump and not be able to drain that way too. So the atmospheric T eliminates any kind of worries about it. Coil is shipped with nitrogen. Again, it's nitrogen under a minimal amount of pressure, guys. I know when I used to say I'd pull those caps off the evap and I'd want to hear that hiss. Sometimes you're not going to hear that hiss because it's just bare minimum pressures in there. And you think that there's a leak, but they just barely pressurize those things for transport. So you're going to release it with you're going to release the nitrogen, you're going to braze up, you're going to evacuate the system before charging with the refrigerant. Make sure the refrigerant pipe layout do not block the service access. So make sure the refrigerant pipes layout do not block the service access. So make sure we can still remove those doors. You're going to purge the refrigerant pipes and indoor coil with dry nitrogen. That's always a must. I can't stress that enough while brazing. And I'll go over that, why that is even more critical in this situation with these units. Use a wet rag or approved heat paste to protect the TXV sensing bulb during the brazing process. I always just remove the whole bulb off of there. You undo the insulation, you undo the strap and take it away from there. Just eliminate any kind of concern that you're going to overheat that bulb. Condensate drain connection, use a thin layer of Teflon paste, silicone, or Teflon tape when making the drain fittings. I always like using Teflon tape. Do not over tighten. You can split that pipe connection. I've been guilty of it myself. Over tightening it, and it's just plastic, so you can split it or ruin your threads inside your 3/4 inch mil PVC adapter. Do not over tighten. I had one guy working for me too that just would use pipe wrenches on that. I was like, oh, Sean, you gotta stop doing that. Blower section. Again, these are pretty easy to get to. It's got the 24-volt tap, 5-tap, which these are, we're gonna make these settings via dip switches, and I'll show you that later. Apply 24-volt to any tap with common connected. So for a go, no-go test, we can apply 24-volt to any of these tap speeds, and we should get the blower motor to go. If the blower motor does not go with 24-volt applied, and you have 220 going to it too, then it's a bad blower motor. So that's a good no-go test. Keep that in mind. Apply 24-volt to one of those connections, and your blower motor should go. Wires are female spades with locking tab. Okay, so that's important, locking tab, because if you go to try to pull that out, it's going to be locked in there. So you're going to have to stick your thermostat flathead down in there. So you might break the wire if you're just trying to pull on it. So keep that in mind. Everything's nicely labeled. Wires are also labeled 1 through 5. So you got a 5/16 with washer holding that blower in. So it's going to be on both sides. You got 2 screws, remove those, and the blower section is going to come out. Easy. Here's a good picture of that strainer. That's all that is. It's like a little filter dryer in there. So technically, if you had a plugged strainer, you could add a 3/8 external bi-flow filter dryer on the outside of the coil and straight pipe that. So keep that in mind. You don't necessarily need that back in there. It's, of course, it's always good to put in OEM product, but if you're in a pinch, you can just add a 3/8 filter dryer up to the outside. Strainer, and these things do get plugged up easy, so make sure you are bleeding nitrogen during brazing, because if you're not eliminating that oxygen in the copper lines when you hit it with the torch, you're going to oxidize that copper. As soon as you release that refrigerant in it, it's going to clean that copper and push all the oxidation ash into the strainer, causing issues. Oh, that's a bi-flow TXV, so it's got a little bypass in there. So in AC, we are using for cooling, we're using the TXV. In heating, refrigerant flows this way and bypasses the metering device. So it is possible when diagnosing and we're in heating mode and we're not working, it is possible our bypass is plugged if our strainer got plugged. So keep that in mind. This is the E4AH5 air handler. So we got a coil temperature sensor. We got LED indication. So it's got a red LED flash on for 0.5 seconds or off for 0.5 seconds. Coil sensor fault will result in anti-cold prevention function being disabled. So we'll go over that anti-cold, but that is sensing the coil temperature. We got a return air temperature sensor, LED indication. So again, there's going to be an LED flash for all these sensors. Return sensor will not result in any failure mode though. So this is just detecting return air temperature. If that does fail, we're not going to failure to any mode. There's a question, do we not field install a filter dryer when we're doing equipment replacement due to there being a strainer in the coil cabinet? Do we not field install a filter dryer when doing equipment replacement due to there being? Yes, so, well, I'll touch on that. I'm a fan of filter dryers, and I did ask the factory if we could do an external filter dryer on this bi-flow, and he said the pressure drop did not affect the system. So we can still install an external filter dryer on the outside of the system, right? Now, if you're doing a retrofit, technically there's strainers in the outdoor unit and there's a strainer in the air handler. There's no strainer in the evaporator coil, so keep that in mind. This air handler, the E4AH5, has a strainer before the indoor TXV. So no, if you are using the outdoor unit with this air handler, you would not need a filter dryer. I recommend it, and I'll go into that here in a little bit. Supply air temperature sensor, again, it's going to have its own separate red LED flash. Anytime we see red flashing, it usually indicates an alarm. Flash on, 2 seconds, 2 seconds off. Supply air sensor fault will result in the supply air heater control being disabled. Incoming line voltage. It is important that the proper electrical power for available connection to the unit model being refer to the unit nameplate wiring diagram. So when we still see this quite a bit, and this should be up to a licensed electrician being able to size that conductor of your line voltage per amperage of the unit. And if you're having electrical inspectors out there, they'll look for that too. But if we don't have an electrical inspector out there, some of the electricians will just, or will assume that the wiring is correct and we'll just, it's a retrofit, it's a direct swap out. We can reuse the existing line set, or sorry, the existing line voltage. But when the electric heat is installed, units may be equipped with 1 or 2 30-60 amp circuit breakers. These breakers protect the internal wiring in the event of a short circuit and serve as a disconnect. So what that's saying, if it's got 260 amp circuit breakers on the heat strip, those are just acting as a disconnect. They're acting as a switch. They're not actually breaking the circuit if the amps are too high. That needs to be sized correctly through the panel. So that's what that's saying. Circuit breakers installed within the unit do not provide overcurrent protection. So that is not your protection if you have undersized wire to the heat strip. So keep that in mind, is just a disconnecting means. We get electricians calling it sometimes, but you guys already have breakers in there. I was like, yeah, but that's not sized for your wire. Your wire is sized according to the amperage of the heat strips, and then the overcurrent protection, if it's going to trip the breaker, that's going to be at the panel. So again, that's important to know. Supply circuit power wiring must be 167 degrees minimum copper conductors only. So of course, refer to the NEC code book for ampacity, wire size, and circuit protector requirements. Of course, our disconnects. We do have a new disconnect out there by Rector Seal, just so everybody knows. It's a disconnect, it's a surge protector, and it protects against brownouts, because we're getting here in the Northwest, we're getting a lot of spiked voltages. We're getting voltages of 267 in some areas. Keep in mind, our max voltage outdoor units are 253. That's a national UL code, 253 max, and we're seeing 267. And we've discuss that with local utilities, and they want you to buy a step down transformer for the residents that are having higher voltage, and they gotta kick that higher voltage up to provide for all the homes due to electrification. Everybody's getting heat pumps, everybody has ACs now, they're doing away with gas lines, everybody's getting electric cars. Yeah, our grid's not handling it, so they gotta bump up the voltage, and it's affecting our equipment. So make sure we're getting surge protectors on it. Ask your local sales rep about that new disconnect slash, and it's like good for 300 times. So you can actually set it in digital relays in there for if it has 5 power surges, it'll lock out the equipment. That way you can go out and inspect and make sure nothing was hurt, and then reset the system. So, and then you know that it's had 5 hits on that unit. So let's protect our equipment, because warranty still covers stuff, but the more stuff we warranty, the more the equipment costs for all of us. So we want to keep the cost of the equipment down. This is without heat strip. I'll show you with the heat strip here in a little bit. Pretty easy to land. So you got your L1, L2 line voltage incoming. We're going to enter incoming power connected here. If the bay heater 16 is not installed, we'll go over what to do with those wires when heat strips installed here in a second. Of course, the rating nameplate, got your 2-ton, you got a 5 and a 10, 5, 10, and 15 for the 3-ton. And we can get up to 20 kW for the 4 and the 60. So that's going to tell you what your circuit breakers are for 230. You got 2 60 amp circuit breakers in there. And then recommended fan speed settings. The 5 and 10 kW require top opening to be used. I'll show you a picture of that in a second. Bottom opening left covered. So you got 2 covers in there, and I'll show you. 15K and above must be dual circuit. I'll show you that in a second. This is important. No single point entry kit is available for this air handler. So there's no single point entry kit where we have one massive sized wire to supply the 20 kW and 2 60 amp circuits, right? So single point entry kits are where you got one heavy sized wire and you're splitting them into 2 different circuits, because that single wire feed from the panel would supply 120 amps possibly. There's our 2 plates. So we got an upper and a bottom. So keep that in mind. We got 2 plates. So if you're going with the 5 and 10, you're always going to use the upper part of it. Prior to installation, thoroughly familiar yourself with the installation manual. I recommend that. Read through the manual on any, it doesn't even hurt if you've installed it a couple times just to see if there's anything new out. You should always read through the installation manual. Give yourself time to read through the installation manual at least once. If you're like me, it takes you 3 times. I got to read through stuff 3 times sometimes to commit it to memory. It's frustrating, but observe all safety warnings during installation or repair. Caution is to be observed. It is your responsibility to install the product safely and to educate the customer on its safe use. Unfasten the 4 screws. Take away the blower access panel of the air handler. So remove the door panel. As you can see, this is a 20 kW. So we have an upper and a bottom. And they are going to have these labels. So slide the heater kit into the slot element with previously removed screws. You guys are probably used to those. You're going to have to line those up. They do line up pretty good sometime. Well, most of the time. I have had a few heat strips where they didn't line up. I'd have to pre-drill my own holes. But I was trying to make something work at that point in time. So it wasn't the OEM heat strip kit for that. Here's the 5 kW, 10 kW, 15, and 20. So you got your double stacks, you got your fuses. Notice the upper and lower. And then once you have the single 5 and 10 kW, you're going to use the upper. But if a 20 and a 15, as you can see, it is labeled upper, lower. So it is kind of fail safe. They only go in one way for proper function. Again, when a single heater is installed, it is required for the upper opening, and you're going to leave this covered. This is in the installation instructions, by the way. Align the attachment clip to the hole, fasten loose wires. Please use our fasteners in there. That's what they're there for. They keep the wires where they're supposed to be. If you do find, and this goes for all equipment, if you find a wire that's rubbing on the wire and you can't, it's pulled so tight and it's still rubbing, I always carried a tube of caulking, a small tube of caulking in my bag. I would put a bead of caulking in between that wire and the said metal part, right? And it creates just a little insulating field in there and it won't rub through. So keep that in mind. That's something I always did on maintenances too. I'd be going into a unit. If you saw a bunch of little bead cocks on the wires, I was probably in there. Then you got the CN20 heater plug kit. So you're going to run it over to the circuit board and plug it into this CN20. There's not much to the board, so, and it'll only plug into that area. So it's going to be really hard. I know it probably can be done. Somebody will do it, but it'll be really hard to plug it in anywhere else. But you'll see CN20, and it also state that in the install manual. As you can see right here, that's a 60 amp breaker, but this could actually be rated for 35 amps. So keep that in mind. This is not a circuit breaker. It is a disconnecting means. It's just a light switch, just gonna allow you to switch that off at the unit. And there's a good close-up picture of that CN20. So here's a picture of that L1, L2 terminal. This is without heat strip. When we do have heat strips in here, we're going to have, say, 20 kW, both these plates come off. We're going to install. We're going to take L1, L2 right here, and we're going to strip off those spades. We're going to strip that back, and we're going to land it on the load side of the heat strip, right? So we're going to land that on the load side of the heat strip. So this, in the beginning, it wasn't stated, so we were adding some wire from L1, L2, but let's now, in the installation manual, it will state remove these spade connectors. You can actually remove this terminal block, and you're going to land that on the load side. This is the line side. This is coming from the panel. The load side is going to all the unit. Excuse me. So after connecting all the wires, check all screws at breaker and make sure all screws are properly tight. I hear this a lot when you guys call into on new equipment. Oh, this was really loose or something. Guys, these things take a beating from Tyler, Texas. Most of them, they're getting transported somewhere, right? Then we load them up, we transport them to the job site. A lot of bouncing around, so this is important. After connecting all wires, check all screws at breaker and make sure all screws are properly tight. That goes for the whole system. It only takes 5 minutes to do it a once over, get your 10-in-1, 11-in-1. I seen the 22-in-1s now. I want one. Go through and tighten all electrical connections. Make sure the power's off and go through and tighten all that stuff. If we have a loose ground, it could cause interference with our boards and then not working correctly. Failure to do so will result in breaker malfunction, fire, death, personal injury. Loose connections in electrical, that's what that is caused, fire. And that goes for your whole home. So I recommend doing a plug-in check every 4 years, going through and all the heat going through those conductors in your light switches at home, expansion, contraction, a lot of it going on. So if you get a loose connection in there, possible fire. When indoor control board receives W1, W2 signal, electric heater will be energized and the indoor blower will be turned on. When W1, W2 signal is off, indoor blower will be turned off. Blower motor runs when G is energized and off is de-energized. So green functions your indoor blower. Just going over what you're doing with the L1, L2. Schematics for 5 kW, 10 kW. As you can see, there's 2 elements for the 10. Each one's a 5. 15 kW. Got 3 5s in there. Notice a 60 amp and a 30 amp. No single point entry kit available. 20 kW. We got 4 5 kW elements. We got two breakers in here, circuit breaker 1, circuit breaker 2. These will both be listed as 60s. No single point entry kit available for these. Let's go back to that 15 because this just came up the other day. He was popping a breaker, right? So see, this one has a 5 kW. So this will be the 30 amp. You got a 60 and a 30. This is critical that everybody knows if we got installers and service techs watching today. Here's our 60 amp circuit breaker. See how there's more of a load coming off of this 60 amp? So what they did is they had aluminum gauge wire, but it went to the 30 amp. And then they had 10 gauge solid core copper, which is rated for 30 amps. And it had on a 30 amp disconnect, or sorry, 30 amp breaker. So they had the 30 amp going to the heavy load one, and they had the 60 amp going over here. Well, this 30 amp kept popping. They could not figure it out. And they had an electrician out there. They went through everything, right? So he's calling me up going, what in the world? We need a site visit. So I had him send me a picture of the indoor because he didn't fully understand the difference of the 60 and a 30. And I said, well, there you go. You have the 10 gauge wire going to the 60 amp circuit. And because these were both labeled 60, again, there's a 15 kW with the both 60 amp labeled, because again, guys, they're just disconnecting means it's a light switch. But you can tell because there'll be more wires coming off the load side of that circuit breaker. That's what's getting all the load. The 30 amp needs to go over here. So we swapped that up, problem fixed. So they had multiple site visits out, or they went out there multiple times. They even had an electrician verifying, and it looked like his aluminum. If you guys have aluminum conductors, they don't carry as much voltage and amperage through them, and they overheat pretty quick. So keep that in mind. It usually takes bigger aluminum wires per code. There's our board. There's our dip switches. Default off position. Red, bad. Green, good. We should all be used to LEDs. Here's the airflow. You will have to set this. So I have not seen any that you just leave in default. So what you're going to want to do is you want to take your static pressure. We go up to 0.8 inch. White, we want to be in the white right here. So tap 2 is factory. Tap 5, high speed. So low speed, high speed. Excuse me. No, this is high speed, right? So tap 4 at 0.5 inches static. This is a 2-ton unit. We'll put out 702 CFM. At 0.7, look how much CFM. So you're not getting as much. So we might want to increase the ductwork to lower that static pressure so we can get some more CFM. So as you can see, that's how that works. So you definitely want to pay attention, and then we can tap 5 is high speed, right? So factory default. Okay, so factory default's tap 2 and tap 5. So this is our low speed, tap 5 is our high speed. Heat pumps require between 300 to 450 CFM per ton. Let's stick with 400 CFM for our area here in the Northwest. And all Trane American Standard units want everything tested when you're charging for at 400 CFM per ton. The shaded boxes fall out of this range. All numbers are calculated at 230 volt with a heater and a filter. So this is calculations with a heat strip installed. So the static pressure drop is with a heat strip installed and filter. There's a 2-minute 2.5 minute blower off delay. So it'll run for an extended 2.5 minutes after a call for heating or cooling has been satisfied. So this dip switches, we do have a cheat sheet on what recommended settings Gensco goes off of. You can ask your sales rep or text into tech services with the email address, and we can send you the recommended dip switch settings. So you can print off and have on your install rigs. Take out some of the guesswork. But the switch 1 through 4 is off. The fan runs at tap 1, indoor coil. So this is the anti-cold air prevention in heat mode. So if we just started up the fan right away, as soon as we get a call for heat, we're going to get a blast of cold air for a little bit before that indoor coil warms up. This is saying it's going to hesitate on that lower fan to come on until that indoor coil temperature reaches 95 degrees. That way, once it starts going, we're going to get a nice warm air. So I do see that. Not very many homeowners notice that, but the elderly might notice that cold draft right away, right? So you might have to take advantage of the cold air prevention in heat mode, but it's there if you need to. And they are labeled, but there's kind of, you can see that switch 2 right there. So this is switch 1 bank, see the 1, switch 2. Not as clear, but and then again with the bank SW2 to 3 is off. Electric heat controlled by supplier temp. Leave that in default. But we have changes if you need to get it above 140 degrees, electric heat off. Not too often it's going to be above that. Again, I suggest leaving that in default too. Heaters on with W1, W2 input. Blower on tap 1 is based on stat input. So we allow the stat to control the W1, W2. So if we have 2 stages of heat, we're going to allow the thermostat to take control of when that second stage heat strip fires up. So again, here's those SW1s, SW3s. We get our airflow settings. And take out some of the guesswork, right? You do need to take your static pressure of the unit. After setting the dip switches, again, when you adjust these dip switches, it does have to be off. Power down the system. Make sure it's off. Switch your dip switches. Turn it back on. Needed to check your total static pressure to determine your airflow. The airflow is required 300 to 450 CFM per ton. Again, we're trying to get to 400 CFM. Cold air prevention recommended off, but you can turn it on if you want. Recommended on. If the dip switch is not mentioned, please leave it alone. That's if the dip switch is not mentioned, please leave it in factory default position, right? So if it's not mentioned, don't worry about it because there's some extra settings in the outdoor unit too. It's for future use. Don't worry about it. Again, all of our air handlers will have these charts in there. I definitely recommend getting familiar with them because you can make some settings and customize it for the airflow. Control wiring is what we're all used to. You got your red 24 volt, you got your common, you got T-stat O reversing valve, indoor B2B. This is important though. The thermostat needs to, all Train American Standard, we're used to reverse valve energizing in heating or in cooling. I'm sorry, in cooling. This one is a heating 4-way. So control option required to energize switchover valve, reversing valve in heat pump heating mode. So in heating, we energize the 240 volt reversing valve. So keep that in mind. It's a 240 volt reversing valve, not a 24 volt. Of course, 18 gauge wire, thermostat wire up to 100 foot. Low voltage should not be running the same conduit as the power wiring. Please keep low voltage away from line voltage because it will interfere with the EMI. W1, W2 input without G will run blower. So that's different too. We don't need a G call to run the blower with our heat strip commands. The board will turn on. And our purple wire defrost is when the outdoor unit goes into defrost, it will energize D, which energizes the heat strip in defrost mode. Single stage thermostat, we're just going to jumper that Y1, Y2. I'll go into Y1, Y2 when we get to the outdoor unit. Again, when you guys are wiring these in, since this is for a gas furnace, right? So the orange reversing valve usually thinks it's cooling. So now that we are energizing reversing valve and heating, we're going to need a separate relay to trick those commands, right? So we're gonna energize this in cooling and energize and take it away when we're defrosting. So you're going to need to add a relay with a gas furnace. For proper defrost, O will need to be energized during defrost. So when it's defrosting, we're going to energize O. Low voltage should not be running the same conduit as the power wiring. Again, thermostat will need to be able to change four-way valve position. Heating is energized. So we're going to have to tell the thermostat that we are energizing reversing valve and heating. And this is that relay 00969. Nice picture of it. Hopefully that's pretty legible. You guys can always call in and we can send this to you too if you're missing paperwork. Here's our downflow only air handlers. Running short on time, so I won't spend too much time on these because these air handlers have been around for a little bit. It does have the EXV. This unit doesn't have a strainer though, so keep that in mind. This unit does not have an indoor strainer. Product dimensions are pretty close. We got 3/4 line set and 7/8 suction side, 7/8 3/8, 3/4 3/8. Again, these are your downflow options. And this is matched. This is ARI matched. You guys should always be installing AHRI matched systems. Yeah, you could probably make some other stuff work, but you're going to possibly run into issues. Downflow applications only. You will need to convert it. So make sure you read through the install manual at least once to see how to convert these things properly. I mean, they give you good pictures on it. So again, that's what's nice. Read through the install manual, refer to the illustrations, and can't go wrong. Bay heater 15. So these A4AH5 air handlers will take the bay heater 15. There will be an installer's guide. There is a single point entry kit available for these downflow air handlers. A little bit different for the heat strip installation. You're gonna snip it out. You're not gonna unscrew. You gotta snip those tabs, and it only has one panel. You're gonna fit the entire heat strip in there and secure it down with the 4 screws in the pre-drill holes. You slide those breakers in, secure with a couple screws. You're going to have to knock out if you remember, if you only have one circuit breaker in there, you will only knock out one of those plates. I've actually did that myself where I accidentally knocked out too many of them. Single point entry kit available. Again, this one has a separate dip switch fan bank, CFM selection light. So when you are actually running indoor fan, this will blink at per how many CFM you have running through it. So it is a nice confirmation for CFM. One through 4 are airflow adjustments, fan off delay, and auxiliary heat speeds. Oh, there you go. CFM light blinks once for every 100 CFM requested. So if you're running at 1200 CFM, it'll blink 12 times. Pause. Here's our setting. So if we're at a 3-ton, our normal's 363 CFM per ton. Here's our high at 408. Let's say high 408 CFM per ton. We want dip switch 1 off, 2 on, 3 on, 4 off. And with our perfect static pressure at 0.5, we will be at a 1221 CFM, 1082 on normal setting. So keep that in mind. Again, this is taking out all the guesswork. As long as you can get that static pressure, you can dial in that fan speed and prove that the system has enough air. If we're off that chart, this one goes up to 0.9. Again, we're going to have to fix the ductwork or find the source of what's building it up. Do we have too small of return, or is it on the supply side? I do have an airflow quick hitter coming up in October, so I do recommend if anybody has questions on airflow, there's great classes on fieldtechhelp.com, and then look towards the October quick hitter, an hour in the morning. We don't go too deep into it, but we go over some airflow tactics, which everybody should know. More airflow adjustments. Again, turn the power cycle down. So turn off the unit, set your dip switches, re-energize. Won't spend too much time on that. Give tech services a call if you guys would like to discuss that a little bit more, or anything in here. You guys can always call in because I know I'm moving pretty quick through this. There's your auxiliary heat speeds. Again, it'll go through. Here's our 3-ton, 2.5, 2-ton, 3.5, 4-ton. These are the airflow settings. So you will have to adjust that per heat strip that you have in there. This actually gives you a pressure drop of what that will be in inches of water column. Minimum airflow. This is important because we could lead to premature failure if we don't have enough CFM going over the heat strips, right? Also, if we have too much airflow over the CFM, but here's a minimum airflow CFM that's allotted for those heat strips. All right, here's the outdoor. So we got the E4HL5 outdoor unit. This is inverter driven rotary compressor. So when you hear inverter, it's capable of many speeds, but the way it's being communicated, it's only 2 speeds. So we got a Y1, Y2. So first stage is 80%. I want to hit this real quick because this is what I've seen in the field. Y1, Y2. So we have a Y1 80% compressor. Y2 will be 100% compressor. On their indoor airflow air handler, Y1 will be 80%, Y2 100% airflow. Okay, what happens when the thermostat sends out for a second stage call? Now you have Y1 low speed energized, and now you have Y2 100% speed energized. What happens is it goes to the air handler ramps up the fan speed to 100%. 100%, then it goes to the outdoor unit and it's calling for full stage compressor at 100%. But there's an inhibitor in here or algorithm that does not allow the second stage compressor to come on for 20 minutes because it's trying to be as efficient as possible. So it will not allow that compressor to kick on. And the only way you can tell that is through taking amp draw. So you're taking an amp draw of the compressor, and after about 20 minutes, you'll start to see that amperage slowly climb because it's going to go in increments. So it is many stages. I think there's like six stages in between Y1 and Y2 until it reaches 100% speed. But what I don't like and what we've had complaints on, it lowers that delta T. It lowers your supply output if you're in heating mode on the indoor airflow. Does that make sense? So instead of getting our 26 degree heating split, we only get like 15 degree. So be prepared. It is doing what it's doing. We've had good reports that it's keeping temp, right? So if the people are setting it at 70 and just leaving it there, they will probably never notice it. If they have a big nighttime setback, the people might notice the lower supply output for that 20 to 25 minutes. So keep that in mind. Liquid gas separator, 1 to 3 ton, 1 fan. It's got accumulator, low ambient cooling down to 5 degrees. We do lose capacity, but you don't need a low ambient kit if you're running this for cooling. It does have a base pan heater installed. So for defrost, it'll melt any ice buildup on the bottom of that unit. Here's some sound rating charts. If you need to check out what decibel levels are at certain power ratings. Again, these are pretty similar to all the ductless units out there. They have wall brackets out there. They have, you can mount them on wall brackets. You can mount them on, I recommend getting them on risers if you're setting them on pads. 6 inches from the exterior, 40-inch to the fan side. So it's a little bit different. They want 40-inch from the fan side. I'd always say 2 foot from the electrical. And that's showing that too. So if you have 2 side by side, it wants 23.6. Round it up, keep it 24 feet, 24 inches. There's some nice illustrations if you have multiple sitting on the roof or some kind of condominium. Prevailing winds, if the location is exposed to strong winds, you must place the unit against the wall to block the wind. Yeah, you want to keep that in mind because these outdoor fans, they don't have much torque to them. So they will spin backwards if it gets hit with high winds. EMI or distortion, indoor and outdoor equipment, cable and wire should be at least 3.2 feet away from TV or radio to prevent static electricity or image distortion. That's saying that we've had some weird things happen where radio towers will interfere with comms and our line voltage and whatnot. So keep that in mind. This is important. Power onto the outdoor unit for minimum 8 hours prior to starting. Okay, so that is so the heat pump can pre-warm the compressor. It needs to be warm before you start it, or you're going to kill that compressor and lead to premature failure. We deal with that a lot. Compressor possibly fails in 3 months, or it could fail within the first year. I know Mitsubishi's pretty particular on that. If they don't honor any kind of compressor issues because it was not preheated. So there's an algorithm in there that preheats the winding. So I recommend as soon as if you're doing a retrofit, get that outdoor unit energized, no control wires, but get it energized, get that preheating of the compressor started. I know I like Jonathan's terminology of the compressor. If you put your hand in your armpit, the compressor should be that warm before you start it. So keep that in mind. The compressor should be about armpit temperature before you start it. Lead to premature failure. Outdoor units are going to come with adapter tubes, 5/8 flare on unit, and a 3/4 inch line. So if you're running 3/4, you can't make a 5/8 flare. So you have to use these adapters. You got a 3/8 and a 5/8 flare on unit with the 3/4, or it can go to 7/8. So use your adapters. They come with the unit. It's just saying if you got a vertical rise, it's going to want oil traps every 32 feet. Most residential case, you're not going to run into that, but maybe we're getting more of these three-story small skyscrapers built. I do recommend always torquing per spec. It takes out guesswork, right? I'm all about eliminating questions and concerns. If you're following the torque specs, with the torque wrench, you have nothing to worry about. You're going to pressure test to 150. That is stated in manual. Braze while flow nitrogen. So you're always going to flow nitrogen. Strainers in the system. I'll show you those. We always want to run a good triple evac. Get it down to 350 microns, and then close the system. And if it states it's got to hold below 500 after a minute, and you got a good evacuate or pump down system. Our 2, 2.5, 3 ton, 3/4, 3/8. 3.5 to 5 tons going to be 7/8, 3/8. Max length's 164 feet on the 4 and 5 ton. 100 foot. So that's something to keep in mind. It's only rated, and these are not in the piping program, by the way. If anybody takes advantage of those piping programs, they are not in the piping programs on comfortsite.com or ASDealerNet. Now here's those strainers. Okay, so what recently happened on one is it wasn't not running correctly. That's where we found that the Y1, Y2 takes 20 minutes to engage full stage compressor. But we also had other issues on this job site where nitrogen was not used during brazing. The homeowner was sitting right there, so he was on top of everything, right? So he was one of those homeowners that followed the guys around. He said, oh, well, they never used nitrogen, and they had a checklist, right? So in the checklist, it was not the use nitrogen while brazing was not checked off. So I was trying to tell the technician on site, this is a brand new piece of equipment, and we had a plugged strainer in the outdoor unit. I was like, hey, why don't you just go ahead, cut that strainer out, straight pipe it with some 3/8 and put it in an external liquid line dryer. And the homeowner refused and wanted a new unit. We could not give them a new unit because that was a factory install, or that was an installation error. They did not use nitrogen while brazing. It was documented on their startup report. Homeowner was right there. They had to eat that cost of the unit. Now, would that have been easier and saved a lot of time if they had an external 3/8 filtered line dryer on it? Yes, it would have. So that's why it prompted me to ask the factory if we could use a filter dryer on these installs. The pressure drops does not affect the system. So with that being said, I recommend using a filter dryer, but not required because these strainers. But if these strainers get plugged, because there's more than one in the outdoor unit, it's a lot harder to swap these out than it is to swap an external dryer. Pre-charge for 25 foot of line. If you have a 50-foot line, you're going to go 25 times 0.32 ounce per foot. Beyond 25 foot, that's your adder. So there are no pressure curves in these outdoor units to do charging. We've asked for them. They are going to act like our standard systems for charging and heating mode. But again, go off of the 0.32 ounce per foot. Beyond the 25 foot, you should be good to go. And verify your second stage compressor is coming on after the 20 minutes by amperage. And you should watch your pressures go up too if you're 100% compressor speed. Only the gas line's insulated, so 3/8 liquid line does not need to be insulated. Outdoor units, a flare connection, indoor unit are brazing. 5/16 access port, so you will need the 5/16 adapter to adapt. There is no true suction line on this, guys. Sorry. So you will not be able to pull a suction pressure, a true suction pressure in heating mode. So again, best way to do it is do the pre-charge for 25 foot if you're in heating season, and then come back and refer to the data plate for what subcooling it is in air conditioning mode. Most likely 10 degrees subcool, but always refer to the data plate because it's possible it changed. Here's our outdoor unit circuit board, our thermostat connection. So there'll be a harness on here that will land. The L is nothing, and D is your defrost. red and common. Here's our reversing valve for B. So B is our reversing valve. So keep that in mind. Digital display, we could cycle through these certain buttons, which are again, key 1, key 2, key 3, key 4. And we have that cheat sheet. So if you want that cheat sheet on how to do that, and then in the installation manual, it does go through how to adjust those settings by pressing 1, cycling through 2, entering through 3. I'm not going to go too deep into it because it's easier when you're on site. Oh, and here's that. So it's default in heat pump. But if you switch this 1 to on, it's cooling only. So keep that in mind if you do just need cooling only. Default or defrost initiate timer defaults 120 minutes. So we do want you to change that to 80 minutes or less because that says it'll allow it to run all iced up for 2 hours. 80 minutes or less, it'll go into defrost more frequently if needed. And compressor lockout defaults -40. So leave that because we want that compressor to keep running as long as it can. Again, we want to change that to the 91.4 S103 or SO3, which that is on our cheat sheet. Excuse me. Allergies are killing me. That just lowers that low pressure protection. This walks you through that the lowest outdoor ambient temperature setting for heating mode. So while project parameters setting menu under the state of selection, press key 2 button to adjust the digital tube to SO1, press key 3 button to adjust, press key 2 button to adjust the parameter value, and then key 3 to save. So it is confusing the first time, second time gets a little bit faster, third time you're cruising. And there's our SO2 default parameter, defrost parameter. We're going to want to change that value to 3 because default 0. We're going to want that parameter for 3. Compressor runs for 80 minutes cumulatively to performing 1 defrost cycle. We're going to leave that one in default. No, we're going to leave that. We want that one to 2. SO3 should be 291. During normal operation, this is what you'll see. 0, no startup signal is received, system idle. So it'll say 0. If it says a 2, we are in cooling mode, 3, heating mode, 4, oil return, 5, defrost, and so forth. So that is in the manual, so you can refer to that if you're curious on what those modes mean. Of course, A will be a failure or protection stop state. So if you see an A on there, something's wrong. There you go, the wiring. Each wire on low voltage harness is labeled with wired destination, so they make that pretty easy. Again, the reversing valve is energized in heat. Anything over 100 foot of thermostat wire needs to be 16 gauge. There's our low voltage on an A951X. A952 variable speed. We have to add that relay for the reversing valve to energize orange. Single stage, we want to just jump Y1 to Y2. Error codes. Again, that'll be in the service facts, installation manual. Give us a call at Tech Services. We can help you navigate those error codes. If you have an 824, 724, you can take advantage of online diagnostics. Again, we can't see all the sensors like we can do on a link system or true variable speed, but we can still see operation runtime, and we still get some information on that diagnostics that's critical for that. We might be able to tell you something before you go out to the job. Real-time and historic operational info, and that's up to 30 days past. So we can see 30 days of runtime, and you can change settings from you. We at Tech Services cannot change your settings, but you as a dealer can. So that is pretty handy. So if you're doing some kind of lockout for dual fuel and you want to make some settings changes, you can do that from your desktop. Don't have to be on site. System health report, so it'll let you know if it's been keeping the house temperature. Yeah, cooling system is failing to maintain. So this might come up if the filter's plugged, right? So if it's not getting good airflow and it's not maintaining heat, that's something you might want to call the homeowner and say, hey, look, change your filter. Over 40 different 24-volt diagnostics alerts. So there's quite a bit of diagnostics you can still do with an 824, and they can use their homeowner app. They can also add wireless sensors to that 824, up to 4 of them too. So if they have an upstairs that they want to average, keep that in mind. So you can average with wireless sensors on those 824 stats. System health monitor. That's all I got for you. Open to any questions. You can always call in to Tech Services. If you want that cheat sheet for dip switch settings and outdoor parameter settings, feel free to text in with an email address. We can share that with you. Ask your sales rep. Anybody have any questions? Well, thank you all for coming and watching that. Hopefully you got some information out of it, and these are good units. We've had good feedback on them, and they're economic. All right, if I don't see any questions in here, you guys have a good day and good rest of the week.